Welcome. Today we're going to talk about graphing and solving absolute value inequalities. Now, in an absolute value inequality, there's a couple of things you have to keep track of. One is if you have the absolute value by itself on the left-hand side. That's the first thing. Absolute value by itself on the left-hand side of the inequality. Once you have that, then you can start thinking about how it's set up. Now, in this one, let's do some numbers. All right, so let's say that's 0. This is 1, 2, 3, 4, 5, 6, 7, 8. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. Okay. If x is greater than 5, the absolute value of x, we know 6 is greater than 5, right? And 7 and 8, and all the ones this way. Is 5 greater than 5? No. But is 5.5 greater than 5? Is 5.001 greater than 5? Yes. So that's why we're going to put an open circle here and all these numbers. The question then is that all of the values that when you take their absolute value, they're greater than 5? The answer is no. What about 0? Is 0 absolute value greater than 5? No. What about negative 7? Is the absolute value of negative 7 greater than positive 5? Well, the absolute value of negative 7 is 7, so the answer is yes. Negative 7, negative 6, negative 5.5. All the way up to negative 5, so negative 5 down is that situation. Now, if we look at this kind of graph, we know this as an OR graph. So this is an OR graph, and this is the graph of x is greater than positive 5, or x is less than negative 5. So the idea here is when you have something in absolute values with an inequality compared to a number, you just can say, drop the absolute value signs, that's your first one. Just drop the absolute value signs, x greater than 5. That's only if it's on the left-hand side and it is all by itself outside the absolute values. So there's nothing added or subtracted or multiplied, divided outside the absolute values. So I write it out once. The second time I write it, again I drop the absolute value signs, but this time I change the direction of the inequality and the sign of the number I'm comparing it to. I will give you some typed notes as part of that. Let's look at this one. Absolute value of x less than 5. Well, let's put those numbers back up again. And I think, let's see, 7, 6, 5, 4, 3, 1. There's 0. All right. So if we think about this, what values of x are in the absolute value are less than 5? Well, we know 0, 1, 2, 3, 4 are definitely less than 5. 4.5 is less than 5. 5 is not, so I'm putting an open circle. Now we know all these values to here. What about absolute value of negative 1? That's 1. And so that is less than 5. Negative 2, negative 3, negative 4. Absolute value of negative 4 is 4. That's less than 5. Negative 4.5. Yes. Is negative 5 absolute value less than positive 5? The answer is no. They're equal. So what about negative 6? Absolute value of negative 6 is 6, which is bigger than 5. So it can't include below there. So there is our graph. And we recognize that as an and graph. What are the two ands? Imagine absolute value of x. Let's drop the absolute value. X less than 5. And, so x is less than 5, and at the same time, x is greater than negative 5. In this one, we drop the absolute value, change the direction of the inequality and the sign you're comparing it to, which is just what we did with the greater than. The only real difference here is the and. So a greater than uses or, a less than uses and. And if you have or equal to, you just include the or equal to. If it's strictly an equals, it's just or. All right, let's take a look at this one. I'm going to write this twice. 8 minus 3n. Notice there's nothing outside. In all the ones I give you tonight, there's nothing outside the absolute value signs, and they're on the left. So I drop the absolute value signs and write it out. A greater than is or. Greater or. The second time I write it, 8 minus 3n, I have to change the direction of the inequality and the sign it's compared to. Now I've got my inequality, and it's just like last night's work where you just solve it and then graph. So I'm going to subtract 8, negative 3n, greater than or equal to negative 1. Didn't realize that one came out to a fraction. Okay. And sometimes that does happen. Divide by negative 3. Now I'm dividing by a negative. That means I have to change the direction of the inequality. N is less than or equal to 1/3. Okay. Over here, I'm going to subtract 8. Negative 3n less than or equal to negative 15. I divide by negative 3. Again, I have to change the direction of the inequality. And we're using or. You always have to keep that or, that connecting word between them. So this is my inequality set. If I were graphing this, n less than or equal to 1/3, n greater than or equal to 5. Boy, I'm surprised that they gave that. I didn't think that was the answer, but it obviously is. And then the or graph. Here's 1/3. Here is 5. So less than or equal to 1/3, solid dot left. Greater than or equal to 5, solid dot right. Final answer, solid dot, left and right. Here, here. There's your final answer for this graph. Let's take a look at another one. Give this one a try. See if you can do it. It's an or graph because of greater. Go ahead. Here we go. M plus 10 greater than or equal to 8. M or M plus 10 less than or equal to negative 8. Subtract 10. M greater than or equal to negative 2. Or subtract 10. M less than or equal to negative 18. All right. So when I graph these, negative 18 and negative 2. let's see, m greater or equal to -2, solid dot to the right, solid dot to the left here, and the two graphs together are an OR graph. There you have it. That is your final answer. In this one, this is a less than, so it's an and. -4 plus 4x less than or equal to 24, and -4 plus 4x greater than, remember you're changing the direction in the inequality and the sign of the number it's compared to, so -24. All right, so I'm going to add 4 to both sides. 4x less than or equal to 28. Divide by 4, x is less than or equal to 7. And remember, if the original inequality, when the absolute value is on the left and by itself, is a less than, then you're going to use and. Let's see, add 4x greater than or equal to -20. Divide by 4, x is greater than or equal to -5. So there is my answer. And now I'm going to graph that answer. X less than or equal to 7, x greater than or equal to -5, and. Less than or equal to 7. Greater than or equal to -5. Where do these two overlap? That's an and. 5, -5, 7, line between them. That's where they overlap. You guys give this one a try and see how you do. All right, so this one is a less than, so -9 and less than 27. I'm dropping the absolute value sign, writing it as is. Connect with and because of the less than. Oops, there we go. And I'm going to drop the absolute value sign. I change the direction of the inequality and the sign of the number it's compared to. Divide both sides by -9, which is going to change the direction of my inequality. Divide by -9, and less than 3. And greater than -3, and less than +3. There's my inequality answer. Greater than -3, open circle, arrow to the right. Less than +3, open circle, arrow to the left. Where do they overlap? Right between the two. Open circles. That's our lesson for today. I hope it was clear. Sorry I rushed a little bit there. Okay.